Hi there, my name's Bruce Rain from Breakers Creations, and in this video I'll be taking a look at the FNIRSI? FNIRSI? I don't know how the to pronounce it. The FNIRSI 2C53T Oscilloscope Multimeter. I love multimeters. I think they're one of the most important pieces of kit you can have in your toolbox. I actually think every household should have one, even if you use it just for checking if that stray battery in the back of the drawer still has some power, or for testing to see if a fuse has blown. Not to mention the safety benefits of being able to check if what you're about to touch has life-threatening voltages. For most, a basic inexpensive multimeter will do. But if you're looking for something a bit special, this oscilloscope signal generator multimeter takes things to a whole new level. Okay, so here is the FNIRSI 2C53T. Let's have a little look inside. And oh, it's got a nice little protective case. I like the blue and black there. Okay, let's open it up and have a look inside. Right, let's start here. We've got a nice little color manual, and that's definitely not my language, but let's have a look through here. Ah, there's my language. Okay, that's great. Oh, charging interface. It runs on rechargeable batteries, 3000 milliamp lithium battery. That is great. I'm very happy to see that. Pop that back in there. And let's have a look at the unit. Out she comes. Right, there it is. And I'll just whip this off. We're ready. And whee! Oh, I love doing that. Okay, so there's a USB in the side. Got a little stand there for standing it up. That's good. That's pretty steady. That's all right. The blue stuff is sort of a rubbery finish, so you know, for withstanding knocks and stuff like that. And the rest is case is a hard plastic. All right. Well, let's have a quick look at what else we have in the box. We have got some leads, standard multimeter leads there, and we have got, I suspect that's probably for the signal generator, and we've got here our oscilloscope leads, and there are two of them because this is a 2-channel oscilloscope, and so these are the standard ones where you can sort of poke through the little hook there, or you can lift that off and have probes there. And then we've got a whole bunch of little color clips here if you want to color code the 2 different leads there. What else have we got? We've got a little USB-C cable for charging, so that's great as well. The specs of the 2C53T specify dual ceramic fuse protection, so I thought I'd open it up to make sure, and here you can clearly see the 2 fuses under the probe ports. We can also see the 3000 mAh battery, which looks like it would be pretty easy to replace when it reaches the end of its life. Interestingly, all the main integrated circuits have the codes blacked out, so I wasn't able to identify any of them. Time for some quick oscilloscope basics. Feel free to use the chapters in the description if you want to skip this bit. A basic way of describing an oscilloscope is like a multimeter that plots its output on a timeline. Allow me to demonstrate. I'm going to test these 2 points for voltage, and I'm getting a stable 5 volts. No problem there, the multimeter has done its job. Now I'm going to test these points here, and the numbers of the multimeter are going all over the place. This tells me the voltage isn't stable, but I don't know much more than that. That's where an oscilloscope comes in. The oscilloscope takes readings really fast. In the instance of the 2C53T, its sample rate is 250 million per second. It then plots these readings onto a timeline, and if those changes are regular, they can then be measured in hertz or events per second. So let's take another look at this fluctuating signal with the oscilloscope instead of the multimeter. As you can see, it's plotting the output here. The oscilloscope shows me the voltage, the duty, which shows the signal is on for half the time and off for half the time. The sharp edges show me this is a square wave rather than a sine wave, but most importantly, the frequency shows me that the signal is repeating itself at 25 Hz,
or 25 times per second.
Other than that, this video is not designed as a beginner's guide to oscilloscopes, but if you're looking for one, I highly recommend this video here. And throughout the following, please keep in mind that I'm not an electronics engineer, I'm just an enthusiast.
The 53T has a 320 by 240 pixel colour display, a 90-degree flip-out stand, and a rechargeable 3000 mAh battery. The USB-C connector on the side can be used for charging the unit or for connecting to a PC to download screen snaps. When you plug in a charger, a small red light indicates it's charging and will change to green when the unit is fully charged. We'll test out the battery life a little later. The 4 probe ports at the bottom are for 10 amp current, 1 amp current, common and positive. The 2 left-hand BNC connectors are for channel 1 and 2 of the oscilloscope, and the right-hand connector is the signal generator output. The probes have the option for 1x or 10x attenuation, and the compensation resistor adjustment is in the probe plugs. The unit includes these little cuffs for colour coding the probes. Ironically, the 2 channel colours on the oscilloscope display are cyan and yellow, but there were no yellow cuffs included, so I went with red instead. Press and hold down the power button for 1 second to switch on the unit. This is very handy as it stops the unit switching on by accident if you happen to bump the power button. A single push is all that's required to turn the unit off. When switched on, the 53T will launch straight into the main menu, where you can choose from Oscilloscope, Signal Generator, Settings, or Multimeter. You can get back to this main menu at any time by long pressing the menu button. Here are the options with the settings. Navigation is super intuitive with the left, right, up, down and select buttons in the middle of the keypad. When you select something, you can press the menu button to go back. You can change the language, but at this time there appear to be only 2 languages supported. The sound and light allow you to control the volume of the beeping and the display brightness. Startup on boot is a great little option. Rather than launching into the main menu, you can specify which function should launch at startup. Given that I will be using this primarily as an oscilloscope, that's what I'll choose. Auto shutdown gives the option for the 53T to switch off automatically when inactive. By default, this is off, but I have a bad habit of walking away while my multimeter is on, so I'll set this to 30 minutes. USB sharing allows you to toggle the USB port into connectivity mode, allowing you to mount the 53T onto your computer's desktop. We'll cover this a bit more shortly. The second last option is About, where you can see the model name and the firmware version. I have upgraded to version 1.07 since filming this. The last option is to reset to factory settings. Exit the settings by long pressing the menu button for the main menu, or use one of the shortcut keys to navigate straight to your function of choice. The shortcuts are as follows. Press and hold down the Move button to go straight to the multimeter. Press and hold down the Select button for the oscilloscope, and press and hold down the Trigger button for the signal generator. Starting with the multimeter, it defaults straight into the Auto or Smart mode. Here it will take its best guess as to what you're trying to measure, either from resistance, continuity, AC or DC voltage. This functionality can be great for novices, but the associated lag in the measurement results is a bit too long for my liking. I would much rather manually set the function to get quicker feedback. Pressing the left and right buttons will scroll through the different measurement functions, which are voltage, continuity and diode, resistance, capacitance, temperature, small current, and high current. Pressing the Auto button at any stage will revert straight back to the Auto mode. When in voltage mode, pressing the Move button will switch between DC and AC voltage. When in continuity and diode mode, pressing the Move button will switch between the two. In temperature mode, the Move button will switch between Celsius and Fahrenheit. And in current measurements, the Move button will switch between DC and AC. The readout also shows a minimum, maximum and average, and at any stage you can press the middle button to hold the measurement. There doesn't seem to be any way of resetting the minimum, maximum and average without swapping to a different function and then back again. Now to the signal generator. Up in the top left is a little status symbol. If this is green, the signal generator is currently outputting a signal. If you press and hold down the middle button, the symbol will change to red, indicating the signal generator has been switched off. The wave options available are sine wave, square wave, sawtooth wave, half wave, full wave, step wave, reverse step wave, index up, index decrease, direct current, multi-audio, sync pulse, and Lorentz waves. You can define a frequency between 1 Hz and 50 kHz at 1 Hz increments, and amplitude voltage between 0.1 and 3 volts at 0.1 volt increments. When relevant, you can also set the duty cycle between 0 and 100% at 1% increments. And finally, to the oscilloscope. Pressing the menu button will bring up all the oscilloscope settings. The first is the display mode, which can be set to the traditional YT or to XY. Cursor measurement can be switched on or off. The options are X1, X2, Y1, Y2, or both. Parameter measurement, which can also be accessed directly with the Parameters button. Channel 1 and Channel 2 settings, which can also be accessed with the Channel 1 or Channel 2 buttons. Trigger settings, which can also be accessed with the Trigger button. Persistence, which allows for overlaying of waveforms to detect minor differences. And mathematics functions. Press the menu button to return to the oscilloscope. Press the trigger button to specify the trigger settings. Auto, single or normal for mode, rising or falling edge, and the channel. If both channels are on, you can select between them. If only one channel is on, that channel will be selected. Press the Channel 1 button to specify the Channel 1 settings. Toggle the channel off or on, select the probe attenuation, AC or DC coupling, and fast Fourier transform on or off. Press the Channel 2 button to specify the Channel 2 settings. Press the Parameters button to select all of the measurement parameters for each channel. You have the option to switch all parameters on or all parameters off. Press and hold the Parameters button to hide or show the parameters on the display. At any stage, you can take a snap of the oscilloscope display by pressing the Save button. Press and hold the Save button to view your previously saved images. Press the Center button to load the image, and press the Parameters button to return to the image list. Press the Parameters button again to return to the oscilloscope. If you want to change the time or amplitude scale, change the horizontal or vertical position, or change the trigger voltage, first select which channel you are using with the Move button. Yellow for channel 1, cyan for channel 2. If you only have one channel active, you can skip that step. Press the Select button to toggle between scale, position, and trigger. When V and H is displayed, the left and right buttons edit the time base, and the up and down buttons edit the voltage scale. When these two symbols are displayed, the left and right buttons control the horizontal position, and the up and down buttons control the vertical position. When these two symbols are displayed, the up and down buttons edit the trigger voltage. To use the cursor measurement, press the menu button, select Cursor Measurement, then select X1, X2, Y1, Y2, or both. Press Menu to return to the oscilloscope. If you have activated X1, X2 cursor measurements, Press the select button until you see X1, X2 at the top of the screen. The up and down buttons will set the position of the X1 line, and the left and right buttons will set the position of the X2 line. The values in the top left will show you the distance between the two in time, as well as the frequency. If you have activated Y1, Y2 cursor measurements, press the select button until you see Y1, Y2 at the top of the screen. The up and down buttons will set the position of the Y1 line, and the left and right buttons will set the position of the Y2 line. The values in the top left will show you the difference in volts. If you have activated both X and Y cursor measurements, press the select button until you see X1, Y1 at the top of the screen. The up and down buttons will set the position of the Y1 line, and the left and right buttons will set the position of the X1 line. Press the Move button to toggle to X2, Y2, and the left and right buttons will set the position of the X2 line, and the up and down buttons will set the position of the Y2 line. The values in the top left will show you the difference between the two. Time for a few practical tests with the multimeter. I'll be comparing the results with my Fluke 115 multimeter. In Australia, this costs almost 3 times as much as the 2C53T. Starting with DC voltage, here are the results for 3 volts, 5 volts, 12 volts, and finally the maximum for my power supply, 32 volts. The results show there is virtually nothing between the two units. Now to AC voltage, and once again the results are the same. The FNIRSI has the added advantage of showing the frequency on the display at the same time as the voltage, albeit a little small, whereas the Fluke needs the press of a button to toggle to the frequency. Now to some resistance testing. Starting with a 1.5 ohm resistor, and there's a little variation between the two, just under 0.2 ohms difference. Now to a 10 ohm resistor, and it's about 0.1 ohms difference. With a 100 ohm resistor, just under 1 ohm difference. A 1.2 kilo ohm resistor, and there's about 2 to 3 ohms difference. Here's a 1 mega ohm resistor, and there's just under 2K difference between the two multimeters. So on the whole, very close results across the board. Now some capacitance tests, and I'll start with a 47 microfarad capacitor, and there's a difference of around 1 microfarad. Here's a 470 microfarad cap, and the difference is a little over 1 microfarad. Now a 2200 microfarad cap, and there's about a 40 microfarad difference. Notice that the 53T is showing the results in millifarads, something I've seen with a few Chinese multimeters. There's nothing really wrong with it, but I prefer working in microfarads, mainly because that's how the capacitors are labelled. And lastly, a 4700 microfarad cap, and there's about an 80 microfarad difference. Once again, negligible differences. I should mention that the response time for reading capacitor measurements is really good, much faster than some other multimeters I've tested. Here is a voltage drop test under diode mode, and only about a 0.02 volt difference. Now measuring the DC current of this little 12 volt motor, and the results are the same. Next up for testing is continuity. For me, the most important thing is speed, and this is why I don't use the auto mode. When I put the two probes together, it's almost 2 seconds before there's an audible beep, while the multimeter tries to figure out what I'm measuring. If I do the same in continuity mode, the beep is almost instantaneous. Having said that, the response speed of the continuity test is a little slow compared to the Fluke. I often use continuity tests for reverse engineering old computers. Let's say I was trying to find out where the ground pin is on this chip. I put one probe to ground, and then I run the other probe quickly down the edge of the chip. When I hear a beep, I can slow down, then move backwards slowly until I find out which pin is ground. I found I had to run the probe much slower than I would with the Fluke. This is a very specific requirement I have, and probably won't affect most users. One thing I would like to see is a visual indicator of continuity as well as the beep. If you're working in a noisy environment or you're hard of hearing, the beep may not be enough. I would love to see FNIRSI make a firmware update that showed some sort of visual indication on the display, as well as beeping when continuity is found. The multimeter also has a temperature mode, but there weren't any temperature probes included with the kit, so I didn't test that functionality. For the signal generator test, I hooked up the 53T to my big oscilloscope. I tried a few different waveforms, a few different frequencies, different amplitudes and duty cycles, and the results were as expected. The oscilloscope readings matched the set output of the signal generator. It's interesting to zoom into the waveforms. Even though some of them look like analog signals, you can clearly see they are digitally generated by these little steps in the wave shape. I'm definitely not an expert in signal generators, but it seems to do exactly what it's supposed to do. My first test of the oscilloscope was to hook it up to the signal generator of my big oscilloscope and see the result. Everything fine here. The auto trigger worked perfectly and the frequency and amplitude readings matched the signal generator output. I also used the oscilloscope with the built-in signal generator, and its readings matched the readings of my big oscilloscope. I had a bit of trouble latching onto the audio wave because of the different sizes of the waves, but a small manual adjustment to the trigger voltage and it was stabilised. Interestingly, it was reading 50 kHz instead of 10 kHz. I assume it was counting all 5 waves in the signal. I used the cursor measurement between the big waves and the results correctly showed 10 kHz. I did a few tests with a vintage Mac I had on my bench. I checked the 3 oscillator clock signals. One for the real-time clock at 32.768 kHz, one for the audio at 16.9344 MHz, and one for the CPU at 31.3344 MHz, which is double the speed of the 16 MHz CPU. I took advantage of the 53T's portability and used it to plot the voltage drop while starting my car. I slowed the time base right down and you can see the voltage here. When the car starts, the voltage dips right down and then rises up once the alternator kicks in. Now I can freeze the output, switch on the cursors and measure the drop in voltage. There was a 4.8 volt drop while the car was starting, a 2.8 volt increase with the alternator running, and it took the car just under 1 second to start. One thing I did notice is I'm going to need a new battery soon. I often use an oscilloscope for checking analog audio signals when I'm diagnosing sound issues on vintage computers. Here you can see my voice as an audio waveform. Once again, my tests are not exhaustive, and that's mainly because my uses for an oscilloscope are pretty basic, and for me the 53T worked beautifully. The auto trigger worked as it should, the readings were accurate, and taking measurements and customizing settings were nice and easy. Transferring saved images is a piece of cake. Plug the 53T into your computer with the supplied USB-C cable. Go to the settings and select USB sharing. The 53T will appear as a drive on your computer. Open up the screenshot file directory and copy the bitmap files across. It's that easy. If you're wondering what the logo directory is, if you copy a 320 by 240 pixel JPEG image here and name it logo2c53t.jpg, you can customize the startup screen. I tested the battery life by running the 53T with the signal generator on and the oscilloscope reading the signal, and I got just under 4.5 hours of continuous use. In summary, the FNIRSI 2C53T is a great little device. It's not a replacement for a larger, more expensive oscilloscope, but it's not meant to be. A unit of this size is always going to have limitations, especially when you consider the small screen and 50 MHz bandwidth.
But it's well made, it looks nice, it's accurate, and most importantly, it's compact and convenient. Typically, I'm checking for clock signals, analog audio and video signals, or for unexpected fluctuations, and the 53T is more than adequate for my requirements. The controls are pretty intuitive and I love the shortcut buttons for switching between functions, but the button controls can be a bit fiddly, especially when using the cursor measurements or changing the trigger voltage. A single press moves the cursor 1 pixel, and holding it down moves it quickly, but I felt like it races away a bit too quickly. When comparing to a traditional oscilloscope, I do prefer knobs over buttons. The oscilloscope probe connectors are recessed into the top of the 53T, and I found plugging and unplugging the probes a little fiddly, especially for my fat fingers. I love the fact that it has a rechargeable battery. I do wish more multimeters had this too. For normal intermittent use, the battery lasted really well between charges. The multimeter display is big and clear, and the on-screen minimum, maximum and mean are a nifty feature. The probes have a lovely fine point on them, the continuity beep is nice and loud, but it would be nice if FNIRSI would add a visual indicator for continuity instead of just the beep, for people who are hard of hearing. And it's a shame they didn't include temperature probes with the kit. The continuity response time is a little slow compared to some of my other multimeters, but still workable. If you're planning to buy one, be aware that there are 2 different bundles available, and the cheapest only has 1 oscilloscope probe included. So if you want to take advantage of the dual channels of the 53T, you'll need to buy the more expensive bundle. Having said that, it's only a few dollars more, so I think it's well worth it. And speaking of price, the unit is currently selling on FNIRSI's AliExpress store for just under $80 US, or for my Aussie viewers, that's 130 Australian dollar dues, which I think is an absolute steal given what you get for the money. Just for comparison, my big oscilloscope costs more than 4 times as much as the 53T. The final word? I think the FNIRSI 2C53T is a great product and worth every cent. Now that I have it, I suspect I may never need my big oscilloscope ever again, so keep an eye out for it on eBay. I'd like to thank FNIRSI for sending me this multimeter to review. I received it for free, but I haven't been paid for my opinions, which are always open and honest. If you're interested in buying a FNIRSI 2C53T multimeter, there is a link in the description. Thanks for watching.